Okay, welcome everyone. Thank you very much for joining us today. Today we have Oleg Mirzov. He works at the University of Lund in Sweden, and he's a specialist in IT and technology, and he's the architect of the ICOS data portal. Correct me. And he's actually going to explain us a little bit today about his work in ICOS. So I think it's very relevant for us, especially because we want to start doing data spaces, and that can be a really good example on a particular data space actually. So with no more delay, please welcome, and you can start. Just tell me when I have to click the screen.
Thanks for the introduction. So yeah, we can just start. Okay, I will with this presentation. I will try to introduce the technical aspects of the foundations of our data portal. So, but first a few words about ICOS. Let's go next to the right. Yes, so ICOS stands for Integrated Carbon Observation System. It's a European research infrastructure. The abbreviation for this type of entities is ERIC, European Research Infrastructure Consortium. And well, it specializes in data on greenhouse gases mostly. It has three themes: atmosphere, ecosystem, and ocean. So it is a little bit cross-disciplinary, or at least cross-scientific community. If we go next, yeah, this is most of our stations, not all of them, is like focusing on continental Europe and the Mediterranean. Spain is now well represented since a couple of years ago. It has 6 stations. 3 of them are not shown because they are on Canary Islands. It was difficult to fit everything in. We have a bigger geography by now. There are also things far outside of Europe as well. Next, please. This is just a flash picture showing the diversity of ecosystems and locations over the stations. Of course, this is by far not all. We are now around 180 stations, which are already operational and aspiring ones. Next, please. Yeah, so you could say that the IT part of ICOS is called the Carbon Portal. That is where I work. So the concept for it was the slogan could have been summarized as a one-stop shop for ICOS data. It's hosted mostly by Lund University in the south of Sweden, but also co-hosted by Wageningen University in the Netherlands, partly. We have some representation there. Yes, down, please. Yeah, that's just where we are. The next down. Yes. So the requirements. We are actually quite old by now. We are going to celebrate 10 years since the official beginning of Carbon Portal this summer. And but so the requirements for it today were formulated already by 2015. There was a number of things. Maybe we don't need to go through all in detail. One technically interesting thing is the first. So there was an interest in tapering resistant traceability of the data, so that you could somehow show that the data has not been manipulated, and basically it was an attempt to thwart the climate skeptics, that you can show that okay, this data has been. You can show the provenance in the detail from the raw data measurement at certain time to the end to the resulting data product showing how much emissions every country emits. So that's a very long-term goal. But so tempering resistance was one technically interesting requirement, and we'll get back to that. Then yes, of course, we need to do long-term preservation, and like the big idea for it was like to have it like an online shopping. like the way you would go find data and you add it to your data card and you say, okay, now I want. But instead of buy, you download, hit a button, and you get it home. That was the original idea. And then another important thing is that, of course, the data producers, people who work on the data, they want to get credit for their work. They would not be happy if Carbon Portal has basically taken their data and presented it as just the ICOS findings. So it's important that scientists who work there, they get attribution. So the citation and keeping the metadata about people and presenting citation information for every data set was important on the priority list. And there was also the machine usability of all the services, and there was a single sign. If we go down.
Down?
Yes. Down. Yes. So those were like the requirements and the big idea, and then here is the technical design choices that have already emerged by 2016 actually. So one idea, like going back to tempering resistance, was that they make the data objects immutable and make the identifiers to be based on cryptographical hash sum of the content. This way, if you publish the identifier, because it is cryptographically strong, you can always later say, well, this is the identifier, it has been published in the past. When you download the object, because there is the ID of the object itself. The URL you're going to download, it contains the hash sum. So that's the solution for the tempering resistance. And for the metadata, we have chosen the RDF stack. I saw that semantic web was one of the research interests of this group, so I suspect you may have heard, even if you don't work. But I can say a few words what it is. There is a slide for that later, just to introduce the basic ideas. Then, well, the APIs are built on HTTP. That's quite a natural thing to expect these days. The other things are a bit, I guess, a bit more technical decisions that maybe we don't have to dwell so much on. Let's go to the next down. So over the years, we have developed quite a number of services, actually, and this is not a full list, I think, but probably the most interesting ones to notice. So we have, so of course, we have the possibility for the data producers to upload the data in a machine-to-machine fashion and also in the interactive fashion. There is a web app for that. Of course, and then there is a set of principles for hosting scientific data you may have heard about called FAIR. Is it familiar? Okay, I don't need to go into details about it. FAIR is an abbreviation, you know. Okay. Right, and then of course it is desirable that people find the data somewhere, so we have a search interface. I will have time for a demo for that. Then one wants to preview the data and visualize it without downloading, and so easy. There's some easy way. Of course, we need to have a metadata database. It is there. Then we have a possibility to run custom design queries against that, so that we don't need to update an API for every user request. We support a standard query language so that we can design or have the users design the queries, or we help them, so that if there is a metadata question that our API doesn't answer, it can be answered with a specially written query. So very low investment way of supporting your users. Yes, there is also an important thing related to the citations. That's we mint so-called PIDs, permanent identifiers. Sometimes also DOIs, that's a special kind of them. Don't know how familiar you are, but DOI, at least, I think every scientific worker has been exposed to DOI because that's what every article gets. It's what the DOI is a permanent identifier together with the minimum set of metadata associated with it. And the PID is usually is just an identifier, and typically at least it has a URL redirect. So basically, if you have an identifier for a data object, you will be able to find where to download it. And then we have a service for counting download statistics. And then like the next layer, so to say, of services, so after the measurement data comes the analysis and processing and elaborated products. So we have web hosted Jupyter notebooks for with direct access to the data and the library, or actually a host of a growing ecosystem of Python libraries for that. Well, another thing that I can mention that we have been successful with is that we actually abstracted. So we originally, of course, it was designed for ICOS only, but we were generic enough. So we were able to abstract the services to serve two other, so to speak, customers. So we have another research infrastructure, a national Swedish one called SITES. And then also there is a spin-off project. It's not quite research infrastructure, but from the technical viewpoint it is. It's called ICOS Cities. It's a spin-off for measurements, atmospheric and some ecosystem measurements in the urban environment. So we have actually, so our stack of software is deployed is serving three infrastructures and deployed twice. If we go next to the right, please. Yes, so a little bit to the details of the implementation. So there is one idea, again, regarding the interesting part quite often can be is how do you distinguish what is data and metadata? It's quite often a philosophical question. One person's data, one person's metadata is another person's data. So for us, we actually drew the line pretty low in the sense that we say the data is just, so we have a notion of a data object. You can think of it as a file, and it has the content of this data object. That's the only thing that we call data. So the sequence of bytes and nothing else, that's the data. Everything else is metadata. So including the file name, of course. So regarding the ID for temporary resistant proof, so this is the design of the ID. So we use an ASHA 256 hash sums, and then you take a base64 representation, or more specifically base64 URL, and then we take the first 24 characters, which is called 18 bytes. That is sufficient, not to be afraid of collisions. Next to the right, please. Yes, so that was all about data. So everything else is metadata. So metadata is, of course, the key to everything is to the fairness principles, is the key to providing the meaningful services to the users. So everything that we make is driven by metadata. So different areas the metadata describes is basically, of course, it is the measurement stations, people, the roles that the people play, the instruments that we use to measure the data, to produce the data. And then, yeah, the data objects themselves, the metadata for them, the provenance, and so on. So the metadata is published according to linked data principles. Yeah, and it's yeah, we use, as I mentioned, semantic web or RDF stack for expressing the metadata and publishing it. Next down, please. Yes, so the very basic metadata about the data object is, well, of course, the PID, that's the first thing, that's the identifier that was designed, as shown on the previous slide, and then it's pretty much file name and its size. That's the basic metadata. Next down, please. Then we have the provenance metadata. That's basically how this object came to be, its origin. And so there are three that we distinguish three types of provenance. So there's acquisition, production, and submission. These are processes, and they have start and end time, and also they have they're called agents. So this terminology is borrowed from a standard ontology from W3C called Prov-O ontology. So these provenance events, they are associated with agents, and by agent is just generic term for person or organization for us. And then if we go down, further down, please. So people and organizations, for us, they are linked together through, we call this, this is a little design pattern, we call it a membership. It's basically a hub, metadata entity that links together people, their roles, organizations, and time. So this way you can very flexibly describe what role people play at organizations, and people can have parallel double roles or triple roles at the same organization if necessary, and in different organizations and so on. So this is a flexible pattern for describing roles. Yeah, role itself is basically, you can think of it as a string event. Principal investigator or an administrator or a data manager and so on. And if we go further down, and then another aspect of the metadata is the content of the data object as such. So of course the data object can be just stored as a block of data which has very little metadata associated with it, but it becomes especially useful if you actually describe what the content is. So that improves the fairness, of course, and it enables a number of very nice services. So we have a certain metadata model to describe for simple tabular objects. For example, we have for time series. These are the most of the measurement data. We have a metadata model that describes what the columns of the data set are. So there's a data object. That's the center. Let me see if I can show. Yeah, I don't know. Okay, right. We have different screens. Okay, then let's forget it.
That object?
Yes. So the data object, that is the center of the metadata universe, actually. So this picture of our metadata universe, and this picture describes the content of it. The idea basically you have something that we call data object specification, and that is a hub that collects many different metadata properties of objects which are repeated. So that we don't need to attach many properties to every single data object. We have an umbrella metadata entities that collect many properties, including the dataset columns and their quantity kinds and value types, what they contain, and the unit of measurements and things like that. Let's go further down.
Down?
Yes, and then so as I mentioned before, so the language or the technology stack used to represent the metadata is called RDF. It stands for Resource Description Framework. That's not very self-explanatory term, but the idea is actually basically a couple of ideas, and they're very simple. So the one idea is that every metadata entity gets a real URL so that you can visit it. So the ID is a URL on the web, which you can put into your browser and then get some information about this thing. And the second idea is that all the information, knowledge, you could say, is stored in the form of simple facts consisting of three components: subject, predicate, and object. For example, a certain person that would have a URL has a name, and then the name would be a property represented by a URL as well, and the name, that would be a literal string. That's an example of a minimal RDF statement that you can have. So the objects can be literals or URIs, and then this way, basically, you can say that the person works at the station, and then the station has a name. So it can be quite deeply nested if necessary. So the data model is called a directed labeled graph. So the objects are pointing at each other. Here we go further out. Yes, here the idea was to show two things. One is the so-called landing page of a data object. So what the landing page is basically where these permanent identifiers, it is a page it is referring to. So typically, you do not want to permanent identifier to refer directly to the data stream. You actually want to direct users to something, to some page where they can read about the data object. So here is an example. Oh. Right. So yes, that's an example of a landing page, and it is pretty metadata rich actually. I think we can. Right. So here is our three types of provenance: acquisition, production, and actually submission down there. We have some download statistics. We have some technical information. We have the previewable variables. We have the map showing where the station is, and so on and so on. The file name, of course, the citation string, the previous versions. Actually, sometimes there could be two previous versions. Sometimes an object can make several others redundant, can update to several at once. And then also we have all this here a warning on the top that actually this object is already outdated. It is deprecated. So there is a newer one, a newer, better one, which extends the data further into the future. So it's easily accessible. And then this way you go to the latest one. So the idea is that nothing ever gets deleted. Everything is permanent. Whatever object we publish stays forever, but it may happen that it becomes outdated, and then you will get the link to the better version. Yes, and then the second is, I guess, could be the bigger demo if we wanted to. That's the
Get out.
F11.
F11?
F11.
Oh, and we were
Yeah, that one. And let's go to the second.
Thank you.
Yes, so this is our flagship product, you could say, I mean, Carbon Portal's flagship product. This is the search interface for the data. The idea is, the basic idea of the interface, I think it is what is called multifaceted search. And so it is, well, I don't know how novel it is by now, but you know, the original experience of websites of this type was that the website would ask you to formulate search criteria. It would be telling, well, like on this type of data and that type of data, and they ask you a number of questions, then you hit the search button, and the result is typically your search gave 0 results. That's a typical experience. So here the approach is quite different. Rather, you are getting everything by default, and then if you want to, and then you filter down. And so as you filter down, you have an interactive experience showing what disappears, what options you have available. So actually by default, when one visits, there are some things that are pre-selected, but one can clear all the filters to get not absolutely everything, but most of the things that we have. So we actually now, in fact, there's not all the objects are being shown, deprecated ones and hidden. We're close to, we're 1.8 million right now. So that actually, when you have a very advanced search interface, it is a considerable performance challenge. So there is a big number of filters, or we could say selectors and filters. One can filter in many different ways. So the interesting ones, well, it depends. Actually, depends on who you are. The interesting ones, but data type is one, which is like the central classification for all the data objects. So we have quite many right now, 88. And well, one can search for whatever. So say if you're interested in CO2, you can type, and then the list gets reduced. So some conveniences that are expected these days are there. So that so if one is interested in a specific atmospheric CH4 product, so you pick it, and then the list of the list of results immediately is filtered down. So you always, the idea is that you will, and then as that happens, what also happens is that for example, the list of stations that produce data. It gets updated to reflect your choice. So this way you will never be able to, or almost never, let's say it gets much harder for you to get zero results. You always see what you can get. And one can, of course, one can start the other way around. One can pick a station, some like this, and then this way the list of data types is reduced. So now it's not 88, now it's only 17, because this particular station only delivers 17 data types. And so on. So there's the data types, they're classified according to project and theme, they can be filtered. And then there is also the what we call continuous variable filters. For example, the dates, one can filter quite flexibly by the dates, so sampling date or submission date when the object was uploaded, or sampling date that is the overlap of the object's temporal coverage with whatever you want, whatever time interval you are interested in. So yeah, I would say that the key idea is that it's interactive and live, and it helps you not to get zero results, so to speak. Yeah, for example, sampling, and then also even the continuous variable filtering, it also reflects in these statistics that you see in these facets. So, for example, we could say that we want, let's say we want data higher than 300 meters, measured at higher than 300 meters. You immediately you see that, well, the data set, the number of data sets was much reduced. And also the stations are now only reduced to only 7. And the data types, they're reduced to 24. So it's a very good tool for exploring actually exploring the data. On top of that, of course, when you find, so that if you remember this idea of a one-stop shop and the shopping cart experience, yes, one can do that. One can add. Well, one needs to be logged in to use this shopping cart idea. Otherwise, you download them one by one. And then it's possible to preview. So, say if we want some release data, it's here to release, and let's see, do we have the release from Spain? Yeah, we do have a release from Spain. That's from Tenerife, and well, we can preview it. Actually, one click for this view. Took a little bit of time, but they were short.
Isanya?
Yeah, it was Isanya.
I cannot find it.
You can choose there it is. Two down. Yeah. You can scroll up.
I click.
Yeah, you can click on this, and then you can click on preview. There is a preview tab next to metadata, a bit higher here. So you just click on the name. You pick the
Parameter. What did you choose?
CO2. Just the CO2. Pick this one. It will work.
Okay.
So basically, I mean, it is a standard feature to expect, but it is necessary. I think something we can brag here is that it is quite well performant. Maybe today is not as impressive, but I mean, this library in the browser, already like 7 years ago, it could manage almost 1 million data points, and they load pretty fast. So we have a good performance on that front. Yes, let's go back to the presentation. Press.
F11?
Yeah, I mean, full screen. Go next to the right. Yes, so these little demonstrations, they are served by two biggest services we have. So one is a metadata server, and another is the data server. So this is I think this is just this slide just shows the basic technical services that that the metadata server exposes. So it's you see down there is the landing pages that we have upload GUI, which I didn't show. One can fetch the metadata in different formats. Then we have the upload API for uploading the metadata. This handle.net client on the left that is for minting the TIDs. Sparkle endpoint that is for accepting the custom built queries about metadata. So there's a number of things that are necessary or have been necessary over the years to support all the numerous requirements. If we go one step down, that's the data server. So that's the one that is hosting the web application for the data search, the one we were looking at just now, and it supports the fetching the data itself in different formats. And also it uploads the data to a third-party trusted repository that's like a backup. And next, right? This is upload. I think this we skip. I will go next, right? Yeah, this is not to explain the details. All this is just to flash a little bit to how to say, like to show off the complexity of the problems one has to deal with. Sometimes when one has three different scientific communities, so they have intermediate organizations, within ICOS called thematic centers. So we have one for atmosphere, one for ecosystem, and one for ocean. And these are completely different people, and they have their own stations under their command, and then they have their own traditions about collecting the data, storing metadata, and so on. So there is quite a bit of a challenge to unify this. And this picture just shows that, well, we have a system to collect metadata about stations, instruments, people, and their roles from them. And it's a different approach for each. So we had to be flexible at Carbon Portal. We had to be flexible and work with each of them to work to integrate everything into a unified picture. And yeah, it's quite some challenges, but it seems to work. And if we go this down, yes. So one of the things also that is interesting to mention is that this approach using the semantic web stack and the RDF and the ontology language that is part of the semantic web, it allows for more generic software. So something. So we have a piece of generic software, a very simple one, was written. It took like 3 weeks of development time very early on in 2015, and it is still serving us as a metadata entry, generic metadata entry interface that can be configured and driven by an ontology. I mean, try and show it. Just a few links from here. So, for example, we have one. One, it looks pretty basic, but oh, this is a Spanish station, closest to us geographically. So this is something that is used by the head office of ICOS to enter the aspiring provisional stations. And so the interface is pretty basic. The good thing about it, as I said, is that all the code is generic. So when we needed another time, we needed an interface, a metadata entry for a different purpose, for our own metadata. Well, we use the same software and just use different ontology to configure it. And there we have a different list of classes and different list of boxes for editing metadata, but the software is the same. So instead of traditionally developing a separate web application for every type of metadata, we have one web application which is configured by ontology that saves us a lot of development time. We wouldn't have we're a small team. We wouldn't be able to afford a separate app for every metadata entry purpose we have. And this is actually not an exhaustive list. It's just a few examples. We probably by now we have 10 instances of this or something like that on this interface. Right? Well, these are the rest are technical details. Again, no need to dig into it. This is just more to flash and for appreciation of the complexity of the system. Well, this is not all of it, of course, but this is the different services and the elements and the communicate. This is what we call communication diagram. It's very helpful when you deploy, when you automate deployment, to know what you have, what databases you have, which services, what they communicate, how they communicate with each other. This is just a general visual impression. We're not going to discuss details. Go further down. Yes, again, pretty technical stuff. We are wrapping up. This is a list of technology choices. So the basically software that we're using and the languages. Yeah, software and the languages. I don't think I need to go through the list very much. This is it's all there. I guess it's familiar for IT people, most of it. Then yes, and then for the details, there are some links. So this whole presentation was a link in the beginning. This is talking about PIDs. This is if you hit you can hit escape and then navigate with the arrow keys. Yeah, you can hit the arrow keys on the keyboard for the navigation screen.
Where you
go left. Go left even. Yeah. Yes. So this is the link. So this is this is UI.org. This is the standard resolution service for all the article DUIs, and but we have a couple of prefixes within ICOS. This is a prefix for PID, actually not a DUI, but this resolution. The resolution service, it works. So I made a little PID for this presentation. So you can, if you get curious about the details and the links, it's all there and it's all online. Just a little convenient URL to remember it by. I think that should be it. I don't want to go into further details. If you have any questions, we can take it as a chat, informal interaction session.
Thank you very much. And yeah, if you have any questions, any comments, this is the moment. Maybe can you check if there's anything in the chat? Okay, thank you. Questions, comments? It was so clear, Oleg.
No, it's probably a bit too technical to have the questions spontaneously. I know.
I think we will have more questions if we manage to do our own best. I was already thinking about it, like, okay, maybe I was very interested in what you said about not creating one specific website for every data, and that saves a lot of management time for you. I think this is the kind of things that is going to be very useful if we manage to get the project on data spaces. And yeah, there was many things that are going to be very relevant, especially with the ontology and things like that. So yeah, maybe this is a good thing that we've been introducing the topic, but we are now in the project proposal writing. And what I see is that if we manage to get the funding, maybe we can do a collaboration in the future at some point to establish the backgrounds of our data space. So it's a 2 years project, and then it will be longer to 5 more years. It will be in total 7 years projects. And in the first 2 years, we are supposed to implement the grounds. So yeah, if we get the funding, I think we will start at the beginning of next year. So eventually we could arrange collaborations, interactions, and things like that. I understand that you have all the technical documentation is available online.
Not all, but we probably, the thing is that we are, it seems like the big trend for us is that we are kind of expanding in terms of the number of customers that we have. So our software stack, as time goes by, we are adopting it to more and more usages. And this will make it important to write documentation for sure. So we have, of course, we have some, but yeah, most of it is from the user perspective and data uploader perspective. Maybe it is on the GitHub, typically on the GitHub pages of our projects. But in the not so distant future, we're going to write the proper standalone documentation for everything. So far, we have just the presentations and the GitHub pages, but the time is coming soon that we will have dedicated.
Maybe you can push it to January 2025. So we have it ready by time. Okay, so thank you very much.
Thank you for coming.
We are closing the YouTube session. So.